So in these questions, guys, it's called changing the subject of a formula. You're going to be given a question like question 2, and what you're asked to do is make sure that p ends up on its own in this equation. Now, the first thing you're going to look at is two things. How many p's are there in the equation? As in, it says 3p, but is there like a p on the other side? So at the moment, we only have one location for p at the moment, and that's the 3p. Second thing is it attached to anything? The p is getting multiplied by 3. Would you agree with that? Therefore, the 3 is the last thing to leave the p. Alright? Is that alright? So here's what happens. Once you accept that anything that's directly attached to the letter you're looking for, that's the last thing to leave it, then it comes really easy. The q is not directly attached to the p because it's being added, or if it's being subtracted, it'll be the same thing. The q goes to the other side. So we're going to get 3p equals r minus q. What would get rid of the 3? Bring it across and divide. Some people also like to think of it this way. You can choose whichever way you want. Some people do it like this, and then they cancel off the 3's. You can see it results in the same answer, right? Okay, let's try another one. An example would be question 6. So 2 followed by 6 at the moment. Question 6. Get q on its own. 3q minus 4p equals 2r. Once again, what's the last thing that's going to leave the q? The 3. The 4p goes to the left. Okay. Then it's multiplied by 3. Q is being multiplied by 3. So what happens when the 3 moves over to your side? Turns into divide. No, only. Remember what we said. It's not technically the opposite. It's what's called the inverse. The inverse of addition is subtraction. So when I moved subtracting 4p over to the other side, it became plus 4p. Exactly. And if it's multiplied by 3 on the left-hand side, it turns into divide by 3. You don't change the sign for multiplication and division. Okay. Any other questions on that way? So question 9, guys. Question 9 is a great one. Now there's another general theme to all these questions. When the letter you're looking for is stuck in a bracket, yeah, you basically free it by multiplying out that bracket. So what happens if I multiply out the bracket? Plus xz equals w. The whole goal of the question is to get the y on its own. Xz goes to the other side. And then the last thing to leave the y is now the x. So bring the x underneath. W minus xz all over x. Alright? What about the likes of question 12? 2, 6, 9, 12, okay? What about the likes of question 12? What would be a major... You're getting t on its own, okay? Perfect. What we've always said since we've began algebra is that if they all don't have the same common denominator, we're going to make sure they have the same common denominator. Top and bottom by 3. Top and bottom by 3. What happens to the 3's? Cancel. Okay. Then it's 3s plus t equals 3r. Which letter are we looking for on its own? So where does the 3s go? T equals 3r minus 3s. Is that okay? Now, so far I've done 2, 6, 9 and 12. They roughly took me only a matter of 4 minutes. Okay, they're quite quick. Now, let's look at the likes of question, I suppose 14 would be another decent one. P plus Q over 2 equals R over 2. What would be a good... sorry, R, just R. Spoilers. What would be a good start off? And then what do I do at the top? And then to get Q on its own, Q equals 2R minus P. So far, how do you rate the difficulty? Okay, now let's go to what really confuses people is when we write a question like question 15. Okay, a question like 15 really confuses people because it's r equals a third bracket p minus q. Now, the way I'd suggest you do something like this is, does anybody remember how to multiply a fraction by a number? So let's say 2 sevens multiplied by 5. Anybody remember how to do that? Yep. So it's top by top. So it's 2 by 5, and the 7 remains unaffected. Because it would be 5 over 1 if anything, so it would be 7 times 1, which is 7. Does that make sense? Now, by this logic, it's p minus q over 1. Because there's nothing underneath them. And we're multiplying top by top, so it's going to be 1 times p minus q. And then it's bottom times bottom, which is 3. Using the same logic you would have used that in first year. Would you like me to go over that one more time? Okay. Now all of a sudden the question's looking very similar to the one we already did. Which letter do we want on its own? Want P on its own. Now, there's you can do it two ways, right? The way I would do it is, remember I was telling you about the spin the other day. I'd write it as this. Does everybody understand why I'm allowed to do that? It's like me saying 2 plus 5 equals 7. 7 is the same thing as 2 plus 5. Did I change the sign? Didn't do anything, just rearranged it, okay? Now, and then what you could say here is that, okay, that's grand then, therefore P equals 3R plus Q, right? Now, some of you wouldn't have done it that way. What some of you would have done was you would have brought over P to the left and 3R to the right. You would have got minus P equals minus Q minus 3R. That's still right. Multiply both sides by minus 1. What you get? P equals Q plus 3R is actually the same thing as 3R plus Q. They're the same thing. See, 3R and 3R plus Q plus Q. Same thing. Okay? So that's 15. Now, might stop it in a second. Number 18. Stop saying videos all the time. Okay. Lads, what's stopping us from doing this question? So what do we do? What happens next? What happens next? We're looking for a Q on its own. So where's the location of the Q? 2PR over the other side. And then the 3 is going to go underneath. RS minus 2PR all over 3. Okay, that's 18. So